Howdy friends, welcome to All About Relay channel. In this video, we will discuss about the black hole, the calm explorer. Imagine the darkest darkness. That's the nature of a black hole. Their power is awe-inspiring as it's terrifying. Over the next few minutes, let's unravel their secrets together. Let's see what lies beyond the edge of the known universe.
Black holes, the most mysterious and powerful objects in the cosmos, born from the remnants of massive stars, they defy our everyday understanding of space and time. These cosmic phenomena possess a gravitational pull so strong, it swallows up everything that comes too close, even light. This makes them invisible to us, yet we know they are out there. Their presence is felt across the universe, pulling and shaping galaxies, including our own. Their gravity is so intense that not even light can escape. A black hole is a region of space where gravity has become overwhelming. Here, the laws of space and time as we know them cease to exist. But to truly understand a black hole, we must first understand its core component, the singularity. A singularity is an object of immense density, packed into an incredibly small space. It's like having a star far more massive than our sun, collapsing under its own weight. It's at this point that the star's mass gets squeezed into an infinitesimally small point. This is the singularity, and its gravitational pull is what creates the black hole. Now picture a boundary around the singularity, a boundary from which nothing can escape, not even light, the fastest thing in the universe. This boundary is known as the event horizon. It's like the edge of a waterfall, where the flow of water suddenly drops off. Just as the water can't climb back up the waterfall, anything that crosses the event horizon can't escape the pull of the singularity. But the event horizon is more than just a point of no return. It's where we see some of the most extreme effects of gravity. As you get closer to it, time begins to slow down. And if you were to look back at the universe from the event horizon, you'd see time racing ahead. Within the event horizon, space and time switch roles. What does this mean? Well, just as you can't avoid moving forward in time, inside the event horizon, you can't avoid moving closer to the singularity. It's a one-way trip to a place of infinite density and gravitational pull. So, a black hole is a singularity, an object of unimaginable density, surrounded by an event horizon, a boundary beyond which nothing escapes. These cosmic phenomena are the ultimate example of gravity gone wild, a testament to the strange and fascinating universe we live in. But remember, anything crossing the event horizon is lost. Black holes themselves don't glow, but the chaos they cause on their surroundings helps us detect them. They're like the universe's stealthy ninjas, hiding in the shadows, but their actions give them away. Let's start with X-rays. Picture a star or gas cloud getting too close to a black hole. As it's pulled in, it starts spiraling around, creating what we call an accretion disk. This disk spins incredibly fast, and the friction between particles heats them up to millions of degrees. When things get that hot, they emit X-rays. By observing the universe with X-ray telescopes, we can spot these high-energy flashes and trace them back to their source. But that's not the only way we find black holes. Sometimes we see the effects of their gravity on nearby objects. For example, if a star is orbiting something we can't see, and it's moving in a way that suggests it's orbiting a very massive object, then that invisible object might just be a black hole. By tracking changes in the star's motion, astronomers can infer the presence of these as cosmic behemoths. Now here's the most exciting method we have: gravitational waves. These are ripples in the fabric of space-time caused by really big events, like two black holes colliding. It's like throwing a stone into a pond and watching the ripples spread out. Gravitational waves were predicted by Einstein's theory of relativity over a century ago, but we've only recently developed the technology to detect them. When we do, it's a clear sign of black holes in action. So, even though black holes are invisible, they leave clues for us to find. Through X-rays, the effects of their gravity and gravitational waves, we're able to locate and study these fascinating objects. We're still learning, and new discoveries are being made all the time. These gravitational waves, only recently detected, confirm black holes violently exist. The most common type of black hole forms when a very massive star dies and collapses on itself. These are known as stellar black holes. When a star far more massive than our Sun exhausts its nuclear fuel, it undergoes a catastrophic collapse. The outer layers explode as a supernova, while the core implodes under gravity's relentless pull. The result? A stellar black hole. Some of these are up to 20 times as massive as our Sun, yet they're so dense they could fit within a city. Now, let's scale up. Imagine a black hole millions or even billions of times the mass of our Sun. These are the supermassive black holes, the true behemoths of the cosmos. Unlike their stellar cousins, we're not entirely sure how they form. One theory suggests they might start as stellar black holes and grow by consuming matter and merging with other black holes. The supermassive black holes aren't wandering the cosmos. They're at the center of galaxies, including our very own Milky Way. They're like cosmic anchors around which entire galaxies rotate. But what if we scale down? Could there be smaller black holes? Theoretically, yes. These hypothetical entities are known as primordial black holes. Unlike their stellar and supermassive brethren, these wouldn't form from collapsing stars, but from the immense pressures and temperatures in the moments after the Big Bang. They could be as small as a single atom, yet as heavy as a mountain. However, despite decades of searching, we have yet to find concrete evidence for their existence. So, from stellar to supermassive to hypothetical primordial black holes, these objects come in a variety of sizes, each with their unique formation story. And as we continue to push the boundaries of our knowledge, who knows what other types of black holes we might discover in the future. Scientists still debate the existence of primordial black holes left over from the Big Bang. Einstein taught us gravity warps time. Near a black hole, time slows down significantly from the perspective of a distant observer. This fascinating phenomenon is known as time dilation. It's an effect of Einstein's theory of general relativity, which states that gravity can cause time to flow slower. So, if you were to venture close to a black hole, you might age slower than your friends back on Earth. But before you start planning your time travel vacation, remember that the immense gravity of a black hole would also have some less pleasant effects. One of these effects is known as spaghettification, and it's as strange as it sounds. The gravity of a black hole isn't equal everywhere. If you were to approach a black hole, feet first, your feet would experience a much stronger pull than your head. This would stretch you out, making you resemble a piece of spaghetti. It's a fascinating, if somewhat unsettling concept to grapple with. But Perhaps the most intriguing aspect of black holes is the speculation about what lies beyond their event horizons. Some theories propose that black holes could be gateways to other universes. This idea stems from the concept of wormholes, which are theoretical tunnels through space-time. The intense gravity of a black hole could, in theory, create such a tunnel. But before you start packing your bags for a trip to another universe, it's important to note that these theories are still highly speculative. Scientists are yet to find any concrete evidence of wormholes, let alone ones that lead to other universes. So, black holes continue to be one of the most mysterious and fascinating objects in the universe. They challenge our understanding of physics, raising questions that we are still struggling to answer. They warp time, stretch matter, and possibly even provide gateways to other universes. Some theories propose black holes could be gateways to other universes, but the science is still very speculative. Scientists are still working to fully understand black holes. New telescopes and instruments constantly refine our view of these objects. Each day, researchers around the globe are peering into the depths of space, trying to unravel the mysteries that black holes hold. Advanced satellites, like the Event Horizon Telescope, are capturing images of black holes with unprecedented detail. Meanwhile, ground-based observatories are tracking the subtle gravitational influence of these celestial behemoths on their stellar neighbors. We are even detecting the faint echoes of black hole collisions that happened billions of years ago, thanks to the pioneering work in gravitational wave astronomy. These waves offer a completely new way to study black holes and other dense objects in the universe. Yet, despite these advances, black holes remain shrouded in mystery. What lies beyond the event horizon, that boundary from which nothing, not even light, can escape? We can speculate, but the truth is, we simply do not know. Black holes challenge our understanding of the universe. They test the limits of our theories and confront us with paradoxes. They are a cosmic puzzle waiting to be solved. In their enigmatic nature, black holes hold the promise of new discoveries, of uncharted territories in our understanding of the cosmos. They hold the key to questions we haven't even thought to ask yet.